Good morning.
Good morning. How are you?
I'm well. Thanks for being patient.
No. It's my pleasure. Okay. I was checking your quiz. The quiz that you submit is great. You have 100, no?
Thank you. Thank you.
Okay, it's okay. All right, but let me ask to you something. It's clear for you that when you connect batteries in series, you increase the voltage, the output voltage, but
Yes.
the intensity, the amps, stay constant, no? And the total resistance in a series circuit at the end is resistor 1 plus resistor 2 plus resistor 3, all of them together when you connect in series. The only that you need to keep in mind is when I connect in series, the intensity stay constant. And the voltage increase. That's important.
Crank it up.
That's for cranking, correct, for cranking.
Bow thruster.
But when you connect the batteries in parallel, you increase the intensity, you increase the flow, the amount of amps storage. However, the voltage stays constant. You understand? For example, in a house battery bank, it's good idea if you connect the batteries in parallel, because you can storage more and more amps, especially if your boat is a sailboat or a catamaran. You need more amps in the house. In cranking, you need more voltage during the cranking. For that reason, the majority of the cranking batteries are connected in series to provide more voltage during the cranking.
Okay.
Okay, that's important. For example, you have the screen in your board, this screen?
Yeah.
Okay. We are going to do a couple of examples. Suppose that I have the start motor of a big diesel engine, and in the start motor I need 24 volts, and I need 800 amps. The start motor requires this. However, I have batteries, and each battery is 12 volts and 200 amps, suppose. Okay, what is the drawing of the connection required for that start motor? What is the secret? What is the number one that you need to calculate? The voltage or the amps?
First, you need to go series 12 plus 12.
Correct. The first one should be what voltage I need. Okay, I need 24 volts. 24. Okay, how can I get 24 volts if I have those batteries of 12 volts and 1200 amps? Okay, probably if I connect two batteries in series, this is the negative, and this is the positive, and I connect in series. What is the meaning of in series? This is the cross cable, and now in between this is the output, and this one I have 24 volts. How many amps I have over there in that connection?
This one, 200.
Two batteries in series, 200. Correct.
Yeah, it's constant.
Correct. 200 amps and 24 volts. But how many amps you need?
We need 800.
Okay, we need 800. In that case, we need to connect other series of this exactly the same. And I am going to connect the negative of both series connected together. And right now, in between both series, what is the voltage that I have?
400.
No, in this moment, I have the voltage.
Oh, 24.
It's 24, correct. 24 volts. And how many amps I have right now?
It is 200 plus 200 is 400.
400 amps. Perfect. And I need 800. Okay. I need other and other. And finally, this is my output positive, and this one is my output negative. How much is the total voltage here?
24.
24. And how many amps I have?
800.
I have 800 amps. Perfect. This is the combination that I need to provide 24 volts and 800 amps. You can combine. What is the secret when you do this type of a combination? That the secret number one is that all the batteries should be exactly the same batteries.
Mm-hmm.
The same type of batteries, the same capacity in amps, and the same voltage. And also, all of them should be lead acid, or all of them should be gel, or all of them should be AGM, should be exactly the same characteristics. Attention, suppose that we have this example. We have two battery banks, and we have a battery charger with two outputs. Or suppose that you have a boat with two battery banks, and you have two sources of power. One source of power is the alternator of the engine, and the other one is a battery charger. When your boat is in the dock, you connect the battery charger, and the batteries are charged with power coming from the battery charger, no problem. And when the boat is running, you want that with the alternator of the engine, you keep the charge of both battery banks fully charged. That's correct?
Mm-hmm.
Okay. And some people say, Mr. Lopez, I am happy with that design because with the alternator, I charge the batteries. And when my boat is on the dock with the battery charger, I charge the battery bank. No problem. But in some cases, Mr. Lopez, when I am in the dock and I start the engine for some reason, immediately the batteries are too hot. Both battery banks, I touch the batteries and the batteries are too hot. Why? Why you think, Eric, that is the problem? What is the issue in that case?
Too much current.
Exactly. This is overcharge because you have two sources of power supplying power to the battery banks at the same time. Suddenly, correct.
You must have a battery isolator.
Correct. In that case, you need a battery isolator or ACR. This
oh, ACR. Oh my goodness.
Yeah.
Oh my goodness.
Exactly, because the technical name is automatic charging relay. Automatic charging relay or battery isolator or battery stabilizer. It's exactly the same. The ACR is a battery stabilizer. What is the function of the ACR? For example, let me show to you this one. Look at this ACR. This ACR that you have here in this picture receive power from the alternator in the middle and send power from each output to each battery bank. To each output per each battery bank. In this particular case, in the case of the picture that you have on the screen, is one input and two outputs. Two outputs. This is a battery isolator used when you have only one alternator and you want to keep fully charged two battery banks. This one have one input and two outputs in order to keep equally charged both battery banks with only one alternator. That's okay?
Okay.
Oh, Mr. Lopez, I want other ACR with the two inputs and 2 or 3 outputs because I have 3 battery banks. No problem. Let me explain. Suppose that you have here a battery charger. and the battery charger is 12 volts. This is the negative, and this is the positive of the battery charger. Okay, I want an ACR with two inputs, one input and the other input from the alternator, two inputs, and three outputs. Three outputs. One output for this battery, other output for the other battery, and suppose that I have the battery number 3 here. This is the positive, this is the negative of the battery. The other output is for the battery number 3. And I have one source of power coming from the battery charger. That's the battery charger. And other one from the alternator. I have two inputs, input and inputs, and three outputs. And doesn't matter if both the alternator and the battery charger are working at the same time. The ACR, the stabilizer, keep the level of charge in the three battery banks equal, exactly the same.
Oh, good. Okay, I see.
When one battery charger is fully charged, when one battery bank is fully charged, the ACR don't send more power to that bank and send power only to the bank number 2 and bank number 3. If all of the banks are fully charged, the ACR dissipates the energy by heat. For that reason, those ACR, they have aluminum fins.
Oh my goodness, very important.
To dissipate the power by heat. This is
do boat owners know about this?
No, this is very important, Eric. Always in a boat, you have minimum 1 or 2 battery banks, one or two ACRs. Depending on the amount of battery banks that you have in your boat, you need ACRs in order to keep the level of the battery bank equal.